Hello everyone, I am Dr. Tokkummaa Geetahun, and I'm going to explain the second topic. The second one is the major trends in the periodic table. As you can see from this picture, electroaffinity and ionization energy are directly proportional. Atomic radius is inversely proportional to electroaffinity, and it is also inversely proportional to ionization energy. So down the group, atomic radius increases. So these all are major trends in the periodic table. They are also named as periodic properties. So we are going to discuss this one by one. So this is a definition of periodic table trends. It is a regular pattern, or it is a trend observed in the properties of elements. It is also known as periodic properties. I already told you about this. So it helps us to understand the behavior and the characteristics of elements. So these are the major periodic trends. So these are atomic radius, electronegativity, ionization energy, electroaffinity. What is electroaffinity? We will also see this one. And the next one is metallic character and also non-metallic character, etc. So let us begin, okay, by discussing these major trends of periodic table one by one. So this can be explained based on nuclear charge and effective nuclear charge. What is nuclear charge? This is very simple. This is a total positive charge in the nucleus of the atom, or it is also equal to the number of protons. So nuclear charge is equal to number of protons. So it is simply number of protons that is available in the nucleus of the atom. So it is also named as atomic number of the elements. And the second one is effective nuclear charge. Z effect. This is the attractive positive charge of nuclear protons acting on valence electrons. And it can be calculated by using this formula. Z effect is equal to Z minus S. What is Z? This is nuclear charge, the number of protons in the nucleus of the atom. S is inner electron. That shields the valence electron. Okay, so that one is simply inner electron, and it can be designated by using capital S. And all the time, this Z effect is less than Z. Effective nuclear charge is less than nuclear charge or number of proton for the atom. For example, let us calculate the effect, effective nuclear charge for sodium atom. So the nuclear charge for sodium atom is plus 11. This is number of proton in the nucleus of the atom. Minus 10. 10 is what? The inner electron. So for example, we can easily draw the Bohr diagrammatic representation for sodium atom. The total number of electrons for this neutral atom is 11. 11 is the total number of electrons for this atom. And the first shell, so this is nucleus. In the nucleus we have 11 proton and also neutron. For example, the mass of sodium is 23. 23 minus 11. Atomic mass minus number of proton, or atomic number. It gives you the number of neutron for that atom. So 23 minus 11, 12. We have 12 neutron in the nucleus of the atom. The first shell contains only 2 electrons. The second shell can have a maximum of 8 electrons. So totally we have 11 electrons for sodium atom. 1, 2, 3, 4, 5, 6, 7, 8. And the third shell can contain only 1 electron for sodium atom, because totally we have 11 electrons. So this is valence electron, okay? Valence electron. And all these electrons are inner electrons, okay? These are inner electrons. Totally how many inner electrons we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Therefore, 11 minus 10. This is equal to positive 1. Plus 1 is the effective nuclear charge for sodium atom. Similarly for magnesium, it is plus 2, because 12 minus 10. 10 is the inner electron for magnesium atom, and the 12 is the number of proton. That is nuclear charge for magnesium atom. So plus 12 minus 10 equal to plus 2, and the plus 2 is the effective nuclear charge for magnesium atom. And when we move from left to right across the period, effective nuclear charge increases. This nuclear charge also increases because atomic number increases. Therefore, nuclear charge increases from left to right across the period. Not only that one, down the group, from top to bottom, nuclear charge increases, okay? But effective nuclear charge is the same. So S is inner electron, that shell is valence electron. And the fact that the inner electron's shell or screen the outer electrons from the full charge of the nucleus is known as screening effect or shielding effect. Therefore, we can explain these periodic trends or periodic properties based on nuclear charge and effective nuclear charge. Okay, the first periodic property is atomic radius. What is atomic radius? This is really very simple. From your mathematics knowledge, you know about radius. Okay, radius is the distance between the center of the circle up to the curve. Okay, this distance is simply known as r. And from this point to this point, it can be named as diameter. In chemistry point of view, atomic radius is defined as the distance between the nucleus and the valence shell of the atom. It can also be defined as, for especially for metals, it is half the distance between the nuclei of the two adjacent atoms. There is an assumption. According to that assumption, metals, okay, one atom of metal touch another atom of metal. Therefore, the distance between the nucleus, half of that distance is equal to the atomic radius for metals. Okay, you can see from this one, for diatomic elements also, radius is equal to half the distance between the nuclei of the atoms. The nuclei of the atom, this is radius, but this one is diameter. For example, this is for chlorine atom. The distance between the nuclei of two atoms of chlorine molecule is equal to 198 picometer. Therefore, the radius of one atom of chlorine is 198 divided by 2. That is equal to 99 picometer. Therefore, radius is equal to this distance over 2. So this is atomic radius. Okay, let us come to the trends. Okay, as you move down a group, atomic radius increases. Why? Why atomic radius increases? Because shell increases. Okay, when we move down the group, shell of the atoms increases. When shell increases, the radius of the atoms also increases. Okay, let us see some examples. This is, for example, the atomic radius for group 1A, metals. Okay, lithium to cesium. The shell increases from lithium to cesium. This is on second. This is the period for lithium is 2. The period for sodium is 3. Therefore, the shell increases. As the shell increases, the radius also increases. They are directly proportional. So because of this reason, down the group, atomic radius increases. As you move left to right, across the period, radius decreases. Why? Because the shell is the same for all elements in the same period. However, extra electrons are added on the shell, and those electrons directly attract with the positive charge of the nucleus. Because of this attraction, the atomic radius of these elements decreases across the period from left to right. Effective nuclear charge also increases. Nuclear charge also increases. Therefore, increasing number of valence electrons is being added to the same shell, and this one reduces the radius of these elements. Okay, atomic radius of period 3 elements. Period 3 elements. Okay, so sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. So when we move from left to right across the period, the radius, atomic radius decreases. For sodium, it is 1.86 angstrom. Angstrom is nothing but it is equal to 1 times 10 to the power of minus 10 meter. So this one has only 1.60 angstrom of radius, and it decreases when you move from left to right across the period. So this table shows you the atomic radius of period 3 elements. So these elements are group A elements. What about for B group elements? For B group elements, by the way, electrons enter an inner shell. Therefore, the valence shell will not increase. Only the inner shell increases. Electrons will add to the inner shell, not the valence shell. So the defect is the same. Because of this reason, the radius should be almost the same. Let us see example for these B group elements. Let us compare Z effect. Effective nuclear charge for iron, cobalt, and nickel. These are B group elements. So iron has 26 number of proton. So Z effect can be calculated by using plus 26 minus inner electron, that is 24. So it is plus 2. And the atomic number for cobalt is 27. One electron goes to the inner shell, d orbital. Therefore, Z effect is equal to 27 minus 25. It is also equal to plus 2. And the third one, nickel. The atomic number for nickel is 28. So the electron goes to inner shell, D8, okay? Z effect is equal to plus 28 minus 26. So it is also equal to 2. They have the same Z effect. Their atomic radius is also almost the same. 124 picometer, that is for iron, 124 picometer for cobalt, and 125 picometer for nickel. Therefore, for B group elements, their atomic radius should be almost the same. So try to identify this one. What about ionic radius? You are familiar about ions. Ions are positively charged and negatively charged particles. So we can classify ions as cations and anions. Cations are positively charged ions and anions are negatively charged ions. Therefore, cations always smaller than the original atom. For example, Na. This one has greater radius when compared with sodium ion. This is cation, okay? Because we have positive charge on this atom. And due to this can be named as cation, sodium ion, okay? All the time cations are always smaller than the original atom. Why? Because of Z effect. As Z effect increases, so the atomic radius decreases. We already have seen about this one. When an electron is lost, electron-electron repulsion decreases, and therefore shielding effect also decreases. The protons are better able to pull the remaining electrons towards the nucleus and decreases the size of that ion when compared with the neutral atom. Conversely, anions are always larger than the original atom. For example, take this one, Cl-. It has greater radius when compared with chlorine atom, neutral chlorine atom. Therefore, anions are always larger than original atom. So can you compare the ionic radius for these ions? And also we have neon atom here. All of them are isoelectronic with each other. What is isoelectronic? This is nothing but atoms or ions having the same number of electrons. All of them have the same number of electrons. So all the time, Na3- has greater, okay, radius when compared with that of O2- oxide ion, and it has greater radius when compared with fluoride ion. It has greater radius when compared with that of neon, and it has greater radius when compared with that of Na+, sodium+, and this has greater radius than magnesium 2+, and it has greater than that of aluminum 3+. Okay, let me show you how cations are formed. Okay, look at this picture. Okay, in this picture, in the nucleus we have 11 proton. Okay, this is the number of proton for sodium atom, because we have one valence electron in the outer